Bismillahirrahmanirrahim. This is actually our first lecture on automatic assembly and is a continuation of the lectures in assembly technology. I think if you return to the previous lectures, we talked about the manual assembly. We talked generally about assembly and the importance of assembly and so on. Then we moved and we talked about manual assembly, how to assemble components manually on a product. Then we talked about the design for manual assembly. Today I want to continue on talking about assembly technology, and this is the first section on automatic assembly. We're going to have some lectures on automatic assembly. Then we are going to talk about the so-called flexible assembly systems. In these lectures, we are going to cover generally the technology of automatic assembly. Then we talk about the mechanisms of moving parts of assembly machine. Then about mechanisms and devices which move components on those machines. Then we are going to talk about design for automatic assembly. We are going to use the same book, which is Bosroid book. The books you can find, actually I gave you the books before, but you can find them in the library, and you can have them soft books if you wish. Right? Let us start our lecture. Automatic assembly. In automatic assembly, the various individual assembly operations are generally carried out at separate workstation. Actually, each part of the product is assembled in a separate station. That means the machine will have as many as stations as the number of parts on the product. For this method assembly, a machine is required for transferring the part completed assemblies from workstation to workstation. Actually, after the part being assembled in one station, this part should be transferred to the next station. And that means you need in each station a device or mechanism to assemble the part. Then you need a transfer system to the next station. Means must be provided to ensure that no relative motion exists between the assembly and the workhead or robot while the operations is being carried out. Definitely, if there is any kind of motion of the product and the assembly head or the robot during the assembly, that will ruin the assembly process. So the work should be stationary, and only the workhead or the assembly head and the robot will do the job. Then after finishing the assembly process, the product or the semi-assembly will be moved to the next station. Continuous transfer. Actually, we have got two types of machines. One of them is continuous transfer. We talked about it when we talked first about generally about the assembly. With continuous transfer, the workhead are moving at a constant speed while the workhead keep pace. While the operations are completed, the workhead return to their original position and again keep pace with the work carries. And that means the work carrier will move, or the work carrier, we mean by work carrier the pallet or the fixture which carries the work, moving between stations, and while it's moving, the workhead will stop doing anything. When it move, when it be stationary under the workhead will go and assemble the component. Alternatively, the workhead move in a circular, and this is another way. instead of having it in a line, it can move in a circular path tangentially to the motion of the work carrier. In either case, the assembly operations are carried out during the period in which the workheads are keeping path with the work carrier. In other words, the assembly head will stay stationary while the fixture is moving until it comes to a position where it stops moving. Then the workhead will do the job and the component or the fixture will move to the next station. This can be in a straight line or in a circular path. Continuous transfer systems have limited application in automatic assembly because the workhead and the associated equipment are often heavy and must therefore remain stationary. This is a problem actually because doing that means the workhead will move, and this actually is going to make things difficult. It is easier to move the job rather than move the workhead. So it is a very rare or very limited application in automatic assembly this way. The other way is to have the workhead stationary and only the work will move between stations. It is so also crucial to maintain sufficient accurate alignment between the workhead and the work carrier during the operation cycle because both are moving. And this is another problem. If the workhead is moving and the work is moving, and even they will stop at some stage to make the assembly operation, but still it is difficult to have accurate alignment when the component is placed on the assembly. Continuous transfer machines are most common in industries such as food processing or cosmetic, where bottles and jars have to be filled with liquids. If you go to any factory like say fuzzy drinks factory, Coca-Cola, Pepsi-Cola and so on, you will find the workhead is moving and also the component is moving. And this actually even in cosmetic industries the same thing is being done. But generally in other industries we find the workhead stationary, will not move except do the assembly while the components and the fixtures moving. Intermittent transfer. Intermittent بالعربي كده intermittent يعني متقطع. Intermittent transfer is the system more commonly employed in automatic assembly as the name implies. The work carrier are transferred intermittently. The work carrier will move from place to place and stop, and the workhead remains stationary all the time. Just the workhead will do the assembly operation and go back and it just does the assembly operation and it will stay on its place while the work moves intermittently. And that means we need a mechanism which will move the work intermittently, and we are going to talk about some mechanisms like Geneva mechanisms and CAM mechanisms which will make this intermittent transfer motion. We are going to see that later inshallah in this lecture. The transfer of all work carriers may occur simultaneously and the carrier will remain stationary to allow time for the assembly operation. These machines are called indexing machines. In some machines, we find the intermittent motion of all the machine can be done at the same time, and this will be as indexing. All the path move, then it pass, the assembly head will work, then it moves to and so on. All of them move at the same time, and this is called indexing machines. And always these induction machines are circular machines. Or transfer can be free, and these machines called free transfer machines. But there are other machines, which are line machine, where the intermittent transfer of parts will happen independently. And when it comes under the head will do the operation, and then the other part will come in respect of other machines, what they are doing, or other heads, what they are doing. Indexing and free transfer machines, those are the same machines. You see the upper drawing, the circle drawing, where the single purpose workhead and the feeding device are feeding parts to the single purpose workhead, and inside this the table, this round table, as the fixtures which move intermittently. And as I said, this is indexing machine. But in the free transfer machine, as you see, it is a line machine where can be even between the stations other fixtures waiting for the dividing head, for the assembly head to assemble them, right? Basic type of assembly machines, as I said, assembly machines can be continuous transfer, and we talk about them. And we said this rarely, but they are used in the cosmetic medicine factories, cosmetic factories, soft drink factories, where they fill bottles. And this can be rotary or inline. And the intermittent workhead stationary, which we are going to concentrate on, the machines can be indexing or can be free transfer, or even the indexing machine can be rotary or can be inline, right? Indexing machines. Factors affecting the choice of indexing machines for the assembly machine. Why we choose indexing machine? The required life of the machine, the dynamic torque capacity required, the static torque capacity, the power source required to drive the mechanisms, the acceleration pattern required, the accurate positioning required from indexing unit. Generally, an increase in the size of the machine increase in its life. This actually the indexing machine uh, generally, if the mechanism is big, the machine life will be longer, and small mechanisms will wear very soon, and the machine life will be reduced. And actually, those are actually the factors which we should think about when we are designing an indexing machine. Indexing machine, the various indexing machines or mechanisms are available for using automatic assembly machines. And typical examples are these mechanisms for indexing machines. The first one is rack and pinion, where a pinion will move a rack, and a piston will move the work from station to station. And this actually for line indexing or online indexing machine. We can use with this rack and pinion a ratchet, so as the fixture will not go back, because the ratchet is one-way motion. After it move it to the direction, the fixture will not go back. Ratchet and ball. In other words, the piston is moved with the ratchet, but the ratchet is not like the previous one in a straight line, but it is inside the ball over the piston, and that means you need a cam instead of having the ratchet directly connected to the rods, right? Geneva mechanism is well-known mechanism, and the number of slits in this mechanism shows the number of stations, and it is used actually not only for indexing machines but for other machines, but is one of the well-known and well-used mechanisms on indexing machines. Other thing which is called crossover cam indexing unit, where the cam will move the indexing blade, which got kind of pins, and the number of pins and the size of the cam will show the number of stations which can be used on this machine. Automatic feeding and orientating. Actually, we need to feed and orientate the parts, because if I want to assemble something, it should be fed from a place to another and to be orientated so as to be fixed on the correct position. There are many known devices used on feeding and rotating parts of automatic assembly. The Institute of Production Engineer UK identified published large number of them. Actually, if you return back to the Institute of Production Engineers UK book, you find plenty of those parts. Here I'm going to talk about some of them. Maybe the most common device used automatic assembly is vibratory ball feeder. Actually, the ball feeder is one of the most common component or common devices used on automatic feeding of parts, and usually it is used for small parts. The vibratory ball feeder, and here it is. It is a very simple. There is a video. I recommend you to see it. You find it in the library about this feeder. The feeder mainly got a base and two magnets, and the magnets are being connected to electricity, and actually it got some kind of suspension springs, usually three of them, and they are inclined springs, and when the magnets are on and off, the springs will vibrate the ball, which is on the top of the feeder. As the ball got a track, and when the ball vibrates, the components will climb the track and come on the orientation unit. Actually, the track usually engraved on a way that it accepts only the parts which on the right orientation. The frequency of vibration and the amplitude of vibration will control the motion of the ball feeder. So when we use this feeder, we have to control the frequency and the amplitude of the vibration. Here is the ball feeder, and as you see, on the top of it there is orientating device which make only one shape of parts, one orientation of the part will move, the other rotation will be removed and come down the ball, and there is an outlet which let the component come out on the desired orientation. Here, a real ball feeder, not a drawing. As you see on the top of on the ball, there are some devices which will let only the part on the right orientation to come out of the outlet of the feeder. Force acting on part in ball feeder. I'm not going to talk about this in general, but we know that there is a friction force which will oppose the vibration force, which is MP A0 omega 2, and of course the angle of the inclination of the pole track, and the normal force, which is against the gravitation force of the weight of the part. I'm not going to go on that. Just this will give you the idea of the mechanism. And here he says this force has provided the normal components of, and he give you the equation of the forces acting on the part in the pole feeder. And here show you the same thing again. Factors affecting the ball feeder speed, and this is very important because the speed of the feeder will give the number of parts which you are going to get on the right orientation. The effect of frequency and amplitude, and this we talked about already. We need to control both of them. The effect of track acceleration, and the track acceleration, of course, which comes from the vibration of the ball. The effect of vibration angle, and this is very important also. The effect of track angle, or inclination of the track. The effect of coefficient of friction between the ball and the part, and usually balls covered with plastic cover so as not to scratch the component assembled. The effective frequency and amplitude, if you talk about it, the lower frequency, the higher the track speed. If the frequency is lower, the higher track speed. The amplitude is important for part forward movement. But if the amplitude is very high, the component will pounce on the ball and will fall down. Usually frequency between 60 Hz to 30 Hz is used. The effect of track acceleration, increase the track acceleration to reduce an increase in conveying velocity. Of course, if you increase the acceleration, you are going to increase the conveying velocity of the components. As the track acceleration is increased further, the impact velocity also increase until at some critical value the part start to bounce. And this is very important because if you increase the acceleration to some level, the part will bounce and fall down inside the ball again. Track acceleration must be kept constant. This is very important. The effect of vibration angle. It has been found that conveying velocity is sensitive to change in vibration angle. Experimental and research work indicates that an optimum vibration angle exists for any given condition, and this is very important, and you can do it by experience. Also, there are relation between the optimum vibration angle and the coefficient of friction of the track acceleration. Right? The effect of track angle, the highest velocities are always achieved when the track angle theta is 0. Of course, if the track angle is 0, parts will not move up. And the forward conveying is achieved only with a small track angle. So we're trying to keep the track angle as small as possible. The mechanical design of pole feeder associates a positive track angle of 3 to 4 degrees in order to raise the pass to the pole outlet. Of course, if it is 0, it's not going to move, but if it is between 3 and 4, it will move up. Theoretically, the ideal track angle must be 0, but that will be unrealistic. Of course, it should be something, and so usually we keep it as small as possible, between 3 and 4 degrees. The effect of coefficient of friction. The practical rank of coefficient of friction in vibratory feeder is 0.2 to 0.8. The value 0.2 represents the values out for steel parts compared on steel track. When the track is lined with rubber, a common practice in industry, the coefficient of friction may be raised to 0.8. Actually, usually we cover the track with plastic or rubber so as not to damage parts. So the coefficient of friction will increase to about 0.8 or the part will slip. Coating can also reduce the noise level resulting from motion in the parts, which is often an important consideration. In industry, if there are many ball fitters working and they are not covered with rubber or plastic, they are very noisy. So one of the reasons why we cover the ball surface with plastic is to reduce noise. And actually, this our lecture. Thank you very much for your attention. And I'm going to continue on those lectures, inshallah. Actually, as I said, we have 4 lectures. This is the first one. And then the other 3 will come. Please go back and read something on the books which I gave you. And there are some videos I think you need to watch. Thank you very much for your attention.